Welcome to Ask and Learn.
We're asked to use energy to find the equation of motion for this, or equation governing the motion of this block here that's supported or restrained by two springs and sliding along on frictionless surface here. So the block, since it's not moving vertically and only horizontally, only has some kinetic energy. And if we use a coordinate x, say here, then we have the kinetic energy in this block is simply 1/2 x dot squared, where x dot is the velocity, obviously. Now we have to look at the energy stored in the springs. So in each spring, we have 1/2 k times the change in length squared. Now the change in length for one spring is going to be minus x, and for the other spring is going to be x. But when we square it, we get the same result. So for each one, we have 1/2 kx squared, and we have two springs, so we have a total potential energy of kx squared. Now, our total energy is the kinetic plus the potential energy, and we know that it's conserved. So we can take the time derivative. Being conserved means that it's not changing with time. So if we take the time derivative, that has to be equal to 0. Now, taking the time derivative of t, we get mx dot x double dot. Okay, so we need to just make sure we use the chain rule appropriately. And so we have mx dot x double dot. And take the time derivative of this, we get 2k x dot. And since this has to be true for all time, we can divide through by x dot and determine that this has to be true for all time. Mx double dot plus 2kx equals 0. And we're given a value of m is 3 kilograms and k is 500 newtons per meter. So here is the equation, the differential equation governing the motion of this block should it be displaced. Obviously, it governs the motion of it too if it's just sitting there, because then x double dot is 0 and x is 0 and everything's satisfied.